Okay, howdy. Welcome back. We're still on topic one, the intro to human factors and ergonomics and basic principles and basic guidelines. And now I'm going to go over the basic process by which we will analyze a system involving humans and, at least in the case of your homework, analyze a problem that occurred in that system and how the system contributed to it. Okay, so, and this comes from textbook chapters 2 and 3. And I think chapter 2 is, chapter 2 is more about design methods. Chapter 3 is more about evaluation methods. All right, good. Okay, so basic and just kind of a tutorial of a few examples of analysis and design methods. So we have a general structure that kind of blends the world of systems engineering and studying a problem in a human system. So the first thing you gotta have something that went wrong or something that could be better. Okay, so you have to recognize something that is the target for improvement, right? This could be, an accident. So for your homework example, it's an accident. It sounds trivial to call it a problem, but that's the way we'll frame it in this case. And now we want to describe the system around that occurrence or that problem state and what contributes to it. All right, so we have a problem, and this might be errors, inefficiencies, safety risks, for example, accidents, of course. Now, once we have our problem, we want to kind of start to conceptually define the system and what our objective is for our analysis. So generally the objective goes with the problem. If the problem is, there was an accident, the objective could be prevent that accident, or find, the system operating safely and effectively could be the objective. So you want to define the constraints that kind of go with the objective of the system, but helps you give some boundaries so you don't have to think about, all of the possibilities in the universe as you want to have a reasonably constrained problem based in reality, right? So strict requirements, the system must do this, or, in order to avoid an accident, we must have these, aspects, or assuming this context, here are the assumptions that go with how I'm defining this system. So to a large extent, the constraints are defined by the analyzing engineer. Okay, so you get to say, okay, here's where I'm going to stop. Here's where I'm putting the boundary of what I'm calling my sandbox, the space where I'm going to define the system and analyze within it. And I hope this will become a little clearer as we give an example here in coming slides. Okay, so now my system is constrained by the basic boundaries, right? And now, driven by the objective here, we want to make a safer, more efficient system. We want to avoid accidents. Now we want to talk about all of the aspects of the system that might reasonably contribute towards that objective, either directly or through interactions. Okay, so that sounds like an entire universe, and it could be. So in order to make this something you can follow actually step by step, it's not so ambiguous, the method, we give categories of things to think about. So, and I'll talk about each of these, but basically the humans, so the people involved, the technologies being used, factors related to the environment, the tasks, how they're being performed, and maybe I'm missing one there. But in general, there's a nice several different domains can be represented by people, technologies, environment, social factors, task factors. Did I say technology? I forget. I've got them listed pretty soon. Okay. All right. So now we've defined our system. And now with that system definition in place, now we can have a much more structured way at looking at how things interact and the quality of certain interactions. So this 1.3 lecture here, I'm going to kind of lay out the basic study methods. The second half of this, we're going to talk about, well, here's actual like ways you can collect data. These are things you can cite in the methods section of your research reports. So anyway, this is, again, this more the general process here, and then we're going to walk through it in an example. Oh, and then, okay, right. So after we study, we find out what are satisfactory, unsatisfactory interactions, where could the improvements be made, then that will suggest the direction for redesign, solutions. All right, so I like to take a lighthearted example here because your homework is a heavy one. But it's also kind of going to stretch your mind a little bit to think about these different definitions. So I hope this works. So let's go ahead and call this circumstance very, relatively benign, cute child making a mess at dinner, when we're out at a restaurant, back in before COVID times when you could just go to a restaurant, All right, so let's call this a problem system. So first of all, we don't need to do any analyses unless we can say there's a problem. And in this case, the problem is what? Let's say insufficient or inefficient consumption of food. Okay, so from the system perspective, and everybody and everything, technology, environmental factor involved, that's coming here. But we need to start with what is the issue that is bringing the engineer to the table, right? So we say in our system, we have insufficient food consumption. So what is our objective then? Well, we want to usually address the problem directly, but the other way of looking at this is the problem is the failure of the objective. That's another way you can set it up. So let's say, all right, well, we want to increase the amount of food. That's one potential objective here. We want to reduce waste, or we want better manners, or something, or whatever I guess manners wouldn't contribute to food consumption. So yeah, so pretty much increase food satisfactorily delivered to the mouth, right? Constraints. So we have to bound our reality now. We have to give ourselves the boundary of our sandbox, right? And these have, I'm talking about all kinds of different assumptions and considerations, right? So all food must be eaten within 60 minutes. I'm just spitballing, but food must be delivered within this range. Food that's on the floor cannot be eaten. No, you can't get something else. This is what you ordered. You're going to eat this. Okay. So then that defines the boundaries so that we couldn't say, oh, we can satisfy this system by just going to McDonald's across the street, getting French fries. Right. So, all right. All right. So now our boundaries. And within that, these are I guess in this case, we've got, 5 categories we want to talk about. So I mentioned the humans, the people. Well, the more generalized way to describe the actors are stakeholders. And so these could be humans, but stakeholders could also be companies, like a corporation is a person now or something, but like to talk about, for example, the healthcare industry, and stakeholders there will be patients, the family members of patients, but they'll also be like the healthcare insurance company that, has a stake in medical decisions, for example. So stakeholders are usually, we're talking about people, especially, in this class, but stakeholders could be other entities. Right. Okay. So anything with some stake or interest in the outcome of the system, in the system achieving its objective. Okay. Good. So functions. Okay. So this gets sometimes a little goofy. In the textbook, they talk about functions and tasks. I generally just talk about tasks. I just kind of want to get right to, well, what is being done. There's like a slight level of hierarchy that's different between them. So functions, would be something like satiate the child, whereas the tasks would be the individual actions which would satiate, so like, acquire food on chopsticks or something and deliver to mouth. All right, so tasks are a little bit of a more granular level than when we're doing these definitions. Tools and technologies, it's the things that are outside of the human that might be, they might be physical objects, or they might be, like, I don't know, access to the internet. Access to information could be, part of the context there. And I guess that's not exactly physical. But environmental considerations. So, what's going on when this child is trying to eat in terms of the noise level, the sound level, the social context imposed by the environment. All right, so let's walk through this silly example then. Okay, so stakeholders. Who has a stake in the objective of this system? Which again, let's just say we are, increasing amount of food into the tummy. Okay, so the stakeholders involved. Well, the child, obviously. The parents have a stake in that. They care if the child successfully gets the food in their stomach. Maybe the restaurant owners, and maybe, by an indirect means, the more food that goes into this child means the less food that goes on the floor and is wasted. So, maybe that, I don't know, maybe that factors into the restaurant owners, stakes. Other customers, right? So if it's a social scene, they're there. All of these people could be affected by the outcome of this system. Functions, right? So satiate the child, keep the child safe and healthy, happy, keep them relatively quiet. And then we have various tasks that would be performed to achieve these functions. Deliver food to the child's mouth in a satisfactory state. I could also look at something like, the function of keeping the child relatively quiet. The tasks could be distraction, or funny uncle jokes or something, so I don't know that they keep them quiet, but so the specific actions here, those would be the tasks towards achieving the functions in the system, which all contribute towards this objective. All right, what's involved then? Tools and technologies. So we have the chopsticks, we have the food, we have the plate, and we maybe have, a parent who's there who could, from the child's perspective, be a tool, of getting food in their mouth. You feed me, and in effect, engaging something outside of the child themselves, engaging another tool, another means of supporting this task. Physical environment, you could talk about, the lighting, the sound level. Those matter because, if, let's say, achieving the function of relative quietness, we have to think about noise levels in that environment. If we don't consider that, that's a key system element that would really add a lot to that analysis, right? So, I'm just picking some of these things that as examples of things that might matter. How much radius does the child have to make a mess, around them before they disturb the other customers? All right, what else we got? Social environment. So basic expectation of behaving in public could be the sort of social pressure, that affects this system outcome. Parents' aversion to making a scene. Maybe the child likes making a scene, then you've got two social factors there, or maybe interesting interactions, right? You can come up with this. And again, I chose an intentionally benign, everyday sort of thing, called it a problem, and this is all an example. And there isn't like a right answer to this, because it is fairly difficult to define what is the interesting or relevant parts of a system when you just basically know, okay, there's a problem here. So this gives a structure for how to break it down, everything that occurred and all the relevant, or the majority of the relevant system considerations in your analysis. All right, so let me just return to slide 1 just so I can show you where we're at. Okay, we identified a problem. We defined the constraints and objectives. Get more food in the tummy. We can't go across the street to McDonald's, so that's outside. That's what's constrained out of what we're doing, right? What are the key system elements? We talked about stakeholders, functions, tasks, tools and technologies, environmental factors. And now that we've defined our system, now now we can choose which study methods are going to be good for us to analyze within this system. But we can appreciate all of these interaction aspects and the system, because, for example, here's an interaction, like maybe the child, comes in extra hungry, and depending on a certain type of food, will eat or not. So I may have to consider, I don't know, that was a bad example maybe, but you have to consider multiple different system elements to see how the outcome, emerges from that. Okay, all right, there we go, examples. Okay, so now that we've defined our system, we're going to do our analysis. The analysis will uncover the problems, and if we are being human-centered, that means we're looking at the human interactions with other aspects of the system. And that's basically what human factors methods will do. So we'll give some examples in the 1.4 version of the lecture. But then once we know where the problems are, we're not done yet. We need to come up with solutions. So it's find the problem with the analysis, or understand the problem and the root of the problem through the analysis, design to fix that problem. All right. Okay, so in a general sense, these are, this is kind of summary of the world of human factors methods when it comes to, like doing a research analysis, and these sorts of professional and academic pursuits, let's say. So a lot of what I do with my students, you would call experimental methods. Like I am, doing formal hypothesis testing, collecting measures that are very controlled by certain variables, the context. Maybe I'm looking at, like, for example, how accurate humans can be after a certain amount of time doing a certain task, or how long it takes them to respond. I can get quantitative values. So it's kind of my preferred way to do this science, but that's really just a preference thing. I just, it satisfies my mathematical side, I suppose. But yeah, so there's basic, like, formal research, hypothesis testing, experimental methods. There are descriptive methods, and these are a little harder to get p-values, for those who like to, nice statistical tests like me, but they are extremely valuable. So these are going to be more like, I didn't go out and say, hey, wear this safety belt on day 1 and wear this safety belt on day 2 and do any quantitative comparison. I instead just did a sampling of what safety belts are people wearing on this job site, and what are your impressions of them. So it's a little more generalized, although it's not loose. Like, there are formal ways to, organize and ask these questions, but they tend to be a little more in the real world, extremely informative, because in the real world is where all of the system interactions really make a difference. But you're not going to get those nice statistical answers, which sometimes, you need for other reasons. So yeah, the analysis here is much more qualitative. Most of the methods I'll talk about in 1.4, the data collection methods, I would call descriptive. And then finally, evaluation methods. This would be like, if you've ever heard of the term, like a usability evaluation or user experience evaluation. It's kind of like a descriptive method, but it's like a controlled, here's something, and it's just a little more subjective in nature by how people would interact with it. So it's kind of between the two. Okay. All right, so as I mentioned, I didn't need to look it up, it's right there. So chapter 2, more of the overview of the design methods. Chapter 3, evaluation methods. I don't know why they did it in that order, because I kind of think of it as analysis and then design, but in any case, they'll, it's kind of blended. So yes, and of course I'd recommend, reading for more detail. This is just a high level intro. Okay, so one of the things I commonly do, when we start anything that's like, hey, we have a problem, and here's the audience, and here's the nature of the issue. The 3 easiest things to ask about from a human factors perspective, like what are the next, give me the day one info. I'd call these a front end analysis, and it's who are the users, what's going on with the humans involved in the system, what are the functions or tasks that the users are trying to achieve, and what are the environmental factors that impact that. So I know I talked about several offshoots of that. We could talk about social environmental factors, physical environmental factors. We could talk about different stakeholders, but in this case we're just going to focus in on the user. So again, this is like a nice rule of thumb. Let's start talking human factors. Somebody gives me a problem and I can say, okay, well, these are the three things that I want you to talk about at the first meeting. Okay. Realize that as you are, collecting these initial sorts of, brainstorms and talking to people, and it's really kind of like the weekend before we start the project sorts of, just get an idea so we can orient things in the right direction. Realize you are collecting data, but be resistant to think you've got it figured out too soon. Okay. The other issue here is when humans will tell you they'll tell you what they want and not necessarily what they need. And a lot of times you should be first interested in what they need, in order for the system to be healthy. So it's okay. I mean, doesn't sound like a nice thing to say, but at the level of an entire system, you can't keep everybody happy. As a hospital CEO, you can't give, Betty that one day off, or whatever, so you can't keep everybody happy all the time and have a healthy functioning system. You can do your best, but that's not the objective. It's at the objective system level. Okay. They don't always, yep, best for the system. There we go. Okay. So real basic example, let's say we have an ATM machine. Okay. So, this might be something where you get hired by a startup company and they say, hey, we're going to make a new app that will be like a mobile ATM. I don't know what I'm talking about, but it's kind of thing where, hey, let's start brainstorming on Monday. So what do you think about coming in? So first of all, the user, remember, so going back to this front end analysis, the user analysis, function or task analysis. I highlighted task analysis. It's a little easier for me to think about the actual actions, and then the environmental factors. So who are the users? Are they people trying to, get a certain, of a certain standard that are going to be, getting out money at certain times of day when they're going to and from their Wall Street jobs? Or is it in the middle of the night, and we have potentially, intoxicated people? Or are they going to be children coming up to this? Who are the users of this system? What are some of their basic demographic characteristics? And sometimes you're kind of making up a story as you go. So you can be empirical. You could say, well, here at this intersection, here are the people who we randomly polled who said, yes, they would use an ATM if it was here. And, you could do that empirically and collect demographic data. Commonly, it's a little more like, let's just be broad in our demographics and to some extent informed, but with intentional randomness so that you get some variability. So I'll show you what we mean, but just for now, the types of factors that you may be interested in that may impact how a user interacts here, their age, their gender, their physical capabilities, for example. And then, what do we need to satisfy our range of users, collect those as data, and understand people's reasoning for wanting things to be a certain way. So, Betty wanted to, get time off on the 4th of July because, well, what's the reasoning? Because she wanted to see the fireworks. And you could say, well, maybe we could just have her work on the top floor and watch the fireworks. I don't know. I'm totally spitballing this. But the idea of, don't just say, hey, what's it got to be? Understand the reasoning for what they might want, and there may be better system solutions. All right. Function and or task analysis, right? So if our goal here, for this system is acquire cash, and I'm going to use a technology to achieve that. I look at the functions of this system. I need to determine if there are funds in my bank account, transfer those funds, dispense cash to me. I need then to talk about the human activities. So take out my wallet, take out the card, remember and punch in the pin. Hopefully remember to retrieve the card if that's all part of my interaction. That would make it satisfactory. And these tasks can be physical. So it could be walk to the ATM, could be, punch in code, or it could be cognitive, remember my PIN, for example, do the mental math for how much to withdraw. So we can map the tasks being performed by the humans, and based on if it's more of, a physical, if the breakdown in the system is more physical, there'll be those sorts of solutions. If it's more cognitive, a lot of times it's things like, well, maybe we give people a calculator, so if that made sense, to do the mental math. So we can look at additional support for humans attempting those tasks. All right, so user analysis, the basic function or task analysis, and then environment analysis. And you've heard me give a few examples where this could be the physical environment, could be more of the social or the cultural, sort of environment in that sense. But if you think about how certain users may try to perform certain tasks in certain environments, all three of those might matter. If we have a wheelchair bound user, you have to think about the physical environment, if that can accommodate it. Things like, are you sure you're doing this interaction task? Here's the human, here's the technology. But if I'm going to try to do this outside, in Michigan, or a northern, cold place that isn't Texas, maybe I'm going to be wearing gloves, and those gloves may affect my, dexterity or whatever for controlling on a touch screen. Actually, I got a new pair of gloves recently, and it seems to be, I can do it right through the glove. So I don't know what's different, but I'd never had that before. It's pretty impressive. So anyway, the environmental factors may impact the quality or how certain tasks might be performed. Okay. Also, the environment, like the physical layout of the environment, could drive a lot of how tasks need to be performed. Hospitals, if they have, a requirement to maintain sterility, this is going to impact, contact surfaces. It's going to impact how, like when we talked about the example with doors, how doors need to open, what sorts of things, do you need to achieve, to get safe passage from one side of a door to another. You need to be able to, make sure no one's on the other side and not touch it. I also have this example from some research that we did at A&M 6 or 7 years ago. Now, about that long ago, where we were looking at neonatal intensive care units. And take a minute and think about how, if the task of a NICU nurse is to maintain awareness of the health state of all of these infants, then how would this open bay model support that? Well, you can see across the room all 15 patients or something, 15 infant patients in the incubators. And this might be really great for that task, whereas it's not great for the task of supporting the family members of the infants that might be sick or need to bond with the the neonate, the preterm infant, for example. So there are these two basic models, and you'll see across the country, some hospitals have an open bay model, some have a single family room model. These are great for privacy and bonding. These are great for awareness and care, and they don't translate so well. So depending on the nature of the task and the priorities, that environment can make a big difference. Environmental factors. Right. And then we're interacting with these task factors. So you couldn't say universally this is good or this is better than that. It's, well, this for doing this type of task with these sorts of characteristics and users, then all of those factors interact. There we go. Okay. All right. So once we've done the analysis, and by the way, that's the next part of this lecture, is here are analysis, like concrete things you could do to analyze, to collect data and analyze them. But now that we know where the problems are in our system, now we can start to propose, test, prototype and test some solutions. So if we said, oh, a root of the problem here is the child's inability to handle the chopsticks, and so maybe a potential solution is, something that makes it easier for that to work with those size hands and that degree of coordination, right? So yes, tools or technologies, we could have different chopsticks. We could have, different ways to, achieve, like we could give the child a fork, right? Or we could give them, something like this, so a little of both. Maybe it's take them out of that environment, put them in, the kitchen at home where the child can make a huge mess and make a scene. And then, maybe that's an improvement of the system of satiate the child. So for example, it's not always going to be technologies. It could be, we can achieve this system objective by taking the child home, right? So if that's not constrained out, so remember we set our constraints. So if it's still an option to say, well, let's take the child out of this setting and then they can make all the mess they want, as long as we're getting them happy and full and satiated, we've achieved our system objective. All right, good. Data sources that could be informing these design aspects. So sometimes it's like, here's the problem. Well, what's the solution is not always immediately apparent. So then there's some best practices and data compendia that can give you some directions. Some of the design standards, which will be posted actually they're going to be in a new module that is, important task or important class stuff right at the top of the module. So I'll make sure the syllabus will be there, the Proctor form, and also military standards and NASA standards. I'll post those. So yeah, data compendia standards, other guidelines, some of them you need to purchase. Some of them, it's nice that Texas A&M libraries will purchase them if you have a legit need for them. At least for me. I don't know for you guys, sorry. Okay, and of course, sometimes you do evaluations with, you design a prototype and you take it back to a controlled group of people and you see how well it performs and you refine it. So that can be part of the process as well. Okay, very good. Now, I mentioned earlier, I would kind of get at the need for randomness, so to speak, intentionally inserted into demographics and how you think about user groups. So when we get into the second half of the course and we talk about anthropometry, it's going to get statistical a little bit, right? So we're going to talk about, things like normal distribution and how we can interpret, how humans in general would fit a normal distribution. And that's true for most dimensions or most of what we'll talk about in anthropometry. It's also kind of true in a conceptual way when you talk about other demographics. So it's kind of weird to say like, oh, a bell curve. But if you think about, there are people that have certain tendencies at a greater extent than others. And then there are also outliers at the ends, right? So you have to think statistically in terms of where are reasonable confidence intervals for where I can capture, the majority of my population, or at least a percentage of the population that I am comfortable saying represents the population. Okay. So I might, for example, say, I want 50% women, 50% men. I might try to get age demographics. I might try to get socioeconomic demographics, well covered. If those dimensions are what matter, right? So anyway, getting all that group of people, to the more representative you have in your sample, the better the outcomes if you're doing a design, right, for the general world. All right, so then let's combine that. You're probably all looking at this during a pandemic. What's that about? So especially the last few years, and hopefully this video is laughed at, in the future when people say, oh, or I remember back in the COVID times, or maybe it's still the COVID times a decade later or whatever. But in times where it's hard to get contact with a group of people, this is an especially a good method. Okay, so things like class projects, right, where you maybe need to collect data with humans. This is something that I would generally say is the next best thing from live humans. So it's basically storyboarding. It's basically character building. Okay, so it's kind of like Dungeons and Dragons, honestly, or like role-playing games, because you define a character and you define a person with demographics that is designed to be representative of your population, but it's also designed for uniqueness and for some variability and randomness to it that kind of help drive some of the way that you'll use these. So we call them personas. So the persona method is the definition of this hypothetical character, this user of your system, could be again informed by I collected demographic data, but it's, however you get to it, it's a lot of times it's a completely fabricated person. And then, you don't feel bad making fun of them, I guess. It's not a real person. But you do want demographic details. And again, I realize what I'm saying here. If you have demographic details and you're making fun of them, I guess don't cross the boundary of making fun of people because of their demographics. Please don't take that as my message here. But basically, you want representative people, but they're made up. So you could, for example, hypothetically ask this person, "Hey, how come you keep screwing up this task?" Okay, and you can get some storyboarding with that. You should be considering extremes, but again, realize it's sort of a statistical approximation here, and the more extreme you get, the broader your range of being represented there. Good. So then storyboard, right? So it's very much like role-playing games. We're not rolling dice or whatever, but it is basically a detailed story that you're making up. Okay, now let me show you what we mean. Okay, so we've done this in the past, where we did some research on how certain weather apps, what functionality and what visuals should they have to be useful for general aviation pilots. So based on the research, we had enough funding to do some experimental data collection, and we collected demographic data from those pilots. But what it ended up being was pretty much who could show up, like who has a pilot's license and can come to the FAA research station on a whim. It's retired doctors. So we had a whole bunch of like some very young, like military, private pilots who happened to fly in for the interest on the research, but a lot of like retirees who had the time and the financial capability to rent small aircraft. So anyway, it was not very representative of who we were designing for. So we ended up using, to some extent, this persona method, to kind of get some richness in our anticipated user group. These are made up, by the way. These are not the three that we actually made up, but I hope this can kind of illustrate what I mean by having characters, right? So these personas, so these are made up people. I actually got pictures. For me, I'm a visual person, so I can start to imagine this person a lot more readily if they have an avatar, right? So let's talk about things like, well, this, Joe Swan here, new professional pilot, just recently graduated from a top flight school. He's got some experience, not a lot. Then I'm starting to talk about things like, well, he grew up in a farming community, and you think, well, what does that have to do with how he would want a weather app? Just think, oh, well, maybe things like rain, or I'm spitballing, right, or certain weather conditions are more meaningful to him. Maybe he's more in tuned, to when those occur. This may impact how he thinks about meteorology. This may impact how he wants to receive his weather information. So you see where I'm going with this. I started with just a random fact. He grew up in a farming community. He's engaged to be married next spring. And I'm just kind of picking character features with some degree of randomness. I'm making a story. But then I let that character act out the story. Like I just said, he wants to see the weather, displayed a certain way. And you have to, step back a little bit and be like, well, wait a minute, am I too lost in a fantasy? But part of doing this is you have several different people represented, several different personas, characters, and you can see how they would all hypothetically interact. And so it's a thought exercise more than anything, but it helps you think about the important demographics of your user group, and inserts a certain degree of randomness like you kind of need, because otherwise you're just, you have to be able to discover how certain things may manifest themselves in the system if you're doing a hypothetical, sort of design exercise. All right. Yeah. So Joe Swan, maybe his decisions are going to be, driven by his upbringing on a farm and the fact that he's got a lot to live for. I hope he's happy to be engaged next spring. Whereas Big Bobby Lee here, maybe he's got a gambling debt and he's trying to, he's has barely any time flying. He just owns a plane and barely got his pilot's license or whatever. So I'm making characters, and maybe Captain Eagleman here. He's so set in his ways that it's really difficult for him to accept this newfangled weather app. He does all of his weather by radio or whatever. So okay, I hope you get that point. I maybe over elaborated on these three hypothetical personas, but that's again the idea is you storyboard. All right, so that's it for this. Thank you, and tune in for 1.4.